Hello everyone, this is Balu. Welcome to my channel Civil Cave. In this video, I am going to discuss about seated angle connection. Here you can see this is a column and this is a beam, and this both column and beam is connected by the angles. Here you can see this is a top angle, it is called as cleat angle, and this is the bottom angle which is nothing but seat angle, and there is a clear gap between the beam and also column, and this gap is almost 2 to 5 mm. Now, whenever you are going to learn about a connection, I follow these fundamental 5 principles. First principle is what is the type of connection, whether it is a moment connection or shear connection. Next, coming to the second thing, that is what is the purpose of this connection. Next, coming to the third thing, what are the applications of this connection. Next, coming to the fourth thing, how this connection is going to fail, that is failure mechanism of this connection. And the last thing, that is based on that failure mechanism, you are going to identify what are the design aspects or design checks you have to do on this connection. These are the fundamental 5 things which I follow if I am going to learn about any connection. I also suggest you to follow these 5 principles so that you can get the perfection among the connection. And this is the normal view. And coming to this is the isometric view of the seated angle connection. Whatever the 5 principles I have said, let me answer those 5 principles in the each and every slide. First thing is, what is the type of connection? This is a shear connection, and many of the people will confuse why this is a shear connection, why not moment connection. And also I already explained about moment versus shear connection in my previous video. If you have not yet watched my video, please go through it so that you can get the clear understanding about moment and shear connection. Now coming to here, this is a shear connection because here already these flanges are connected to the angles, but it is not a moment connection because this is a simply supported beam. That means this beam is simply supported on this seat angle, and only the reaction which is coming from the beam is going to be transferred into the column. There is no transfer of moment. Remember this important point. Next, coming to the purpose of this connection is to just transfer whatever the reaction coming from the beam to the column. To make that beam as a simply supported, we are using this connection. Next, coming to the applications, these whatever the connections, these are used in the floor systems especially. And next thing, what is the role of this top angle and also bottom angle? Top angle is nothing but cleat angle and bottom angle is seat angle. The purpose of this cleat angle is to give the stability against the lateral torsional buckling. Next, coming to the seat angle, it is just act as a simply support from the beam to the column. Here you can see whenever the load is going to be act on this beam, the beam is going to be buckle in this lateral direction. You can see clearly. So this is nothing but the lateral torsional buckling. Here whatever the 2 to 5 mm gap is provided for the flexibility of the beam. And next, coming to the failure mechanism of the seated angle connection. Here you can see this is a beam which is connected to the column. For example, just you consider it is not exactly as a seated angle connection, but for the explanation of the failure mechanism, I just consider this image, and you can see this is a seat angle, and for example this load is acting in this direction, and this is a top cleat angle, and this web angle, anyway it is not present in our connection, seated angle connection, but for explanation I just consider this image. Assume that this web angle is not present, and whenever the load is going to be act, and this entire load is going to transfer as bearing in the bottom seat angle, and of course whenever the load is going to increase, the connection is going to be rotate with respect to the center of rotation, and also the whatever the seat angle is going to be bent. And you can see here this top angle, because of this loading, the plastic hinge is going to occur in the connection of this horizontal and also vertical leg of this top angle, and because of this formation of this plastic hinge, there is a cut will be formed at this intersection of this top vertical and horizontal legs of this top angle. And you can observe whatever the bolts present here, this is going to be pull out, or you can say the tension is going to act in these bolts. I already discussed regarding the whatever the eccentric out of plane connections. In that eccentric out of plane connection, here the bolts and also load which are in is not in the same plane. In that case, the tension is going to be act in that bolts. This thing I already explained in my previous videos. So please watch those videos so that you can get the clear cut picture among the connections in the steel structures. So you have understood the whatever the failure mechanism. Now what are the design checks you have to do? You have to check whether the bearing length which is presented on the seat angle is it enough to transfer load from the beam to the column. And also you have to check the shear capacity of these bolts, and also next bending in the bottom seat angle, and coming to the pull out or tension capacity of the top cleat angle bolts. All these things you have to check, and also there is a shear transfer in this top cleat angle bolts also. Now whenever the whatever the load coming from the beam to the column is very high, in that case this whatever the bottom seat angle is going to be stiffened with the extra angle. That is, you can see here seat angle they have going to provide extra so that it increase the stiffness of the bottom seat angle. And whenever this extra seat angle is provided to increase the stiffness of that bottom seat angle, in that case it is no more acting as a flexible connection. It is going to act as a rigid connection, and whatever the reaction which is coming onto the seat angle and this whatever the bolts which are connected to this extra stiffener and also the flange of the column, these bolts must be checked for the bending capacity. Okay, not only the shear, you have to check these bolts for the bending also, because whenever you are going to provide the stiffener angle, at that time it is going to act as a rigid connection. Next you can check the bearing length, that is whatever the reaction which is coming from the bottom seat angle, it is going to disperse in the 45 degrees angle, and you have to check the whatever the length of this bearing, that is B1 plus TF plus R1 is going to be enough or not to transfer that load which is coming from the beam to the column. This is also very important. Here you can see this is some pictures which I have taken from the journals. Here you can see this is a load which is acting, and this is the angle. As the load is going to increase, you can see this is a failure propagation in the angle, and slowly the plastic hinge is going to occur at the vertical and horizontal leg of this angle. And because of this plastic hinge formation, you can see this is a fracture initiated, and there is a formation of plastic hinge at the intersection of the vertical and horizontal leg of the angle. And you can see here clear cut fracture or crack which is occurred in between the horizontal and vertical legs of the angle section. You can see here this is a failure pattern of the angle section in the seated angle. Hope you understand the failure mechanism and what are the design checks which you have to do for the seated angle connection. And thank you for watching this video. If you like my content, please like the video and also share with your friends, and also click on the subscribe button so that you never miss the updates regarding my channel. Thank you.